Welcome to part 3 of a series on threading and async and parallelization. If you have missed parts 1 and 2, it's just going back and watching them. Here we're going to pick up where we left off. In the first 2 parts we created a task that has both CPU work and I/O work, and now we're going to go ahead and just parallelize that task with threads. The code has gotten a bit more complicated, but not too bad. There are 2 threads, a I/O thread, reading thread, and a compute thread that's doing our CPU work. There is a blocking queue that they're going to use to communicate. So the reading thread will read each file and then take the buffers that it reads in, put them onto the queue. The compute thread is going to pop those buffers off and do the compute task and then finish up. This should give us the picture that we had before. This picture is our goal, where we are doing the CPU work while the next read is running. So let's give it a run and see what we actually get. Alright, almost 14 seconds. It is a little faster now because I'm running this outside of Visual Studio, but that's been giving me more reliable speeds so I don't have to see the Visual Studio startup time. But this is what we expected to see. We were getting 22, 23, 24 seconds before when we had to do it all on one thread. So we sped up and our speed is pretty much matching what we were getting with the pure I/O task. Let's take a look at our visualization and confirm it is behaving how we expect. Alright, so we now have 3 threads, our main thread, our I/O thread, and our CPU thread. Looks like our I/O thread is spending most of its time blocked, waiting for I/O, which is good. That's what we'd expect. Let's zoom in here. And we see our I/O thread is reading in a block, reading in a block, reading in a block. It's spending very little time in the CPU actually active, spending pretty much all of its time blocked. And then when it finishes reading in a block, our CPU thread kicks off and starts processing that block. So this is pretty much exactly the picture that we had before, although I got the thread order switched. So at this point, our simple threading implementation is done. We got the speed up that we expected, and everything is working as we expected. And a normal threading tutorial might end here, but we're going to look ahead a little further and make the task a little more complicated. This is fine for, say, a batch task where you know you need to process 100 files, and it's very simple. And you can set up these 2 threads and negotiate in this way. But let's pretend that instead of one batch task, we're getting in a bunch of requests on some kind of web server. And maybe each request is to process a single file. And we might have a burst of up to 100 requests. So instead of one job, which is to go and read 100 files, and we know it, so we can set up the queue, get the 2 threads started, and go have them churn through that 100 files. What if we just had a bunch of jobs coming in, each one to read a single file, and we didn't necessarily have any connection between them? The common solution, and what we're going to do, is to use a thread pool. So each time you need to read in a new file, a new task arrives, you add a new task on that thread pool and you process through it. And that's going to put a bit of a wrinkle into our implementation here. So we will take a look at that in our next video.